class, here's an example of how I use statistics in my everyday life. As you all know, I have a rather large family. This family feels like they need to eat, every day in fact, sometimes even up to 5 times a day. This means that we need a lot of groceries at our house. One of my favorite places to shop is Costco, but every time I go to Costco, I end up spending a lot of money. So what I wanted to find out is, am I really saving money by buying in bulk and shopping at Costco? Or would I be better off shopping at a large super saver grocery store like Walmart? I decided to put it to the test. First, I gathered my favorite crew of grocery store helpers. Me and my crew went to both Costco and Walmart and gathered prices on commonly bought groceries and also household items like toilet paper and laundry detergent. We only compared items that were exactly the same at both stores in every way except for the size. When we were done, we had data on 33 different items. Of course, I wanted to be sure I was comparing apples to apples, so I converted everything to a per unit price. For most of the grocery items, this was a per ounce price. This was a matched pairs design because the items that I compared at each store were the same, meaning that the Costco and Walmart samples were not independent. The appropriate way to analyze data from a matched pairs design is to first compute the differences within each pair and then do a one-sample t-test on the differences. I took the Walmart price minus the Costco price, so a positive difference would indicate that Walmart was more expensive, and a negative difference would indicate that Costco was more expensive. For this test, the null hypothesis was mu equal to 0, versus the alternative that mu was not equal to 0, where mu represented the mean difference in price, taking Walmart minus Costco. I used a two-sided test because I wanted to know if Costco was cheaper or if Walmart was cheaper. Here's a histogram of the differences. This little red dot indicates where we would expect the mean difference to be if the null hypothesis was true. As you can see from the histogram, the center of the histogram is nowhere near the little red symbol, which indicates that there is a clear winner in this price battle. We found that there were 2 items that were cheaper at Walmart, and the remaining 31 items were cheaper at Costco. The average price difference was about 5.4 cents per unit. Using the mean and standard deviation calculated from the differences, I got a t-statistic equal to 9.21 with a two-sided p-value of essentially 0. This is really, really small, and we all know that if p is low, HO must go. We would reject the null hypothesis and conclude that the alternative is true. Because our mean difference was positive, we can conclude that Costco is cheaper. The mean difference was about 5.4 cents per unit, which might not seem like a very big number, but remember, we measured the per unit price. So if I'm buying a 40-ounce container of goldfish and I'm saving 5.4 cents per ounce, you can see how the savings can really start adding up. So for example, on a typical shopping trip where I might buy Cheerios, goldfish, string cheese, bottled water, and yogurt, I would save $16.95. And over time, that savings will just multiply. So as a result of this study, I can continue to shop at Costco, and now I know that I really am saving money. And if I bring my family to shop with me and we fill up on the free samples, I might be able to save myself from making dinner as well.